This time we're going to create a few more arrays. So we've covered some basic integer arrays and that sort of thing, which usually ends up looking a little something like this. And you tell it how big you want it to be. Array 1, 0 equals, a number. Array 1, 1 equals some other number. Now I can't go to array 2 because it doesn't exist. And if I run this code, it's going to crash because this only has a 0 and a 1 slot. So that doesn't work. Now I can do integers. I can also do doubles. And I can make them as big as I need. Array 2, 0 equals 3.14. Array 2, 1 equals 12.54. Like so. And of course we could do characters, strings. It doesn't really matter what data type. You can even do objects, which we'll get to at a later date, but string. And let's see here. So for this, we've got array 3. 0 equals Bob. Array 3, 1 equals Barker. And this is a string, so it has to be a string, as you can see. And of course I can make this 3, 5, 10, however many slots I need. We could also do characters. And a character is just simply either a letter, it can also be a number. As long as it's got a little apostrophe around it, it's a character. Or a weird symbol even. Now I can only have one. If I try to put a second one in there, it's not a character anymore, it is a string. Now you can do this one at a time. You can also come down here and just do it like this. And that will make an array of size 5. With those specific numbers in slot 0, 1, 2, 3, and so on. 0, 1, 2, 3, 4. So if I were to print any of those, and I couldn't just say numbers. This is a common problem people will do. They'll try to print the entire array by doing this. And that doesn't work. You'll see you get this funky looking gibberish, basically. And that's because numbers is really just a pointer. It points to the location where these numbers happen to be. Now, I think I've given the analogy of it's a building, and each one of these little places is basically an address in that building. That's how you access that particular information. So I can only specifically say print this particular number, and it'll print that specific number. Now I can do this on one line if I already know the numbers or items I'm going to need. If it was a character, of course, I could just put quotes or apostrophes around them. I could put quotes, Bob, comma, Barker, in parentheses. If you don't know the actual items, you can just set the size. And actually, you don't even have to set the size initially. I can just say int n, just like this. And then later on, I can say, n equals new int, 100, and set that size. Now, whenever I want to print any of these, obviously we can use our for loop, for int I equals 0, I less than. Now here's an issue. 2, I plus plus. I specifically say 2, right? I print, and let's just say array 1, I. Now this will print specifically that first array, 0, 19, 20, oh, well, I'm sorry, 19 and 22, which is my first array that I'm printing here, 1922. The 4 is coming from this print before. Now, what if I wanted to print, this, numbers? Well, I can come down here and change numbers, right? Numbers. But the problem is, it's going to print 1, 2, but not the rest. I'm going to have to come up here and change this to 5. I'll have to change it every single time I want to do something. There is actually a shorter way. Numbers dot length. An array has an extra little item attached to it. Array4 dot, and that's this dot length. And what dot length does is it will tell you how big an array is, how many items are in it. So if I say numbers dot length, I don't have to put a number in. It'll print all of it. If I went in here and changed this to array4 dot length, array4, I don't have to put in the numbers. It'll just print like that. So this actual loop here could be copied and pasted into pretty much every single project, and you just have to change this name of the array you want to print, and it will print every single element, even if there were 1,000,000 in the array. This numbers, if that was size 1,000,000, would print all 1,000,000 of them. I wouldn't have to change anything in this code whatsoever. So instead of having 1,000,000 lines of print statements, I just need the one. And then I just need to tell it to loop that many times. So this is how you can actually compress your code in these later programs. When I tell you that a program can take 100 lines of code or 500, this is typically how you can actually squash it down. When you've got arrays and you've got loops, I can print all 1,000,000 lines if I want to, which is a single couple of lines. Now these would be your examples of other arrays. Let's see, you could also do Boolean arrays, which I didn't write up there, but Boolean, it works the same way. Equals new Boolean, 10 or something. And that's just true, false, true, false, true, false. This is actually really, really useful for programs when you have triggers, actually. It's a name for an event trigger. You have initiated a certain conversation. This trigger is set to true. You have got a certain item or a certain level or done a certain thing. You finished this mission. You killed this boss. Then a trigger is set to true. So when you go to a certain area, if that trigger is true, poof, event occurs. And you could have a whole array of these triggers that are used for pretty much everything in your game. Now this is just a general setup of your basic arrays, all one-dimensional. We'll get into multiple dimensions later, but shouldn't be too hard, hopefully, to play around with this a little bit. Be creative, make a couple of them, different sizes, plug in different values. Try printing them as well. Oh, and there is one other way, which I'll get to later as far as printing them. Java actually has some built-in stuff that you can use that's particularly useful. But again, we'll get to that later. If you have any questions or problems, just let me know.